Good morning, grade 4 girls. How are you today? Today we will complete our lesson. How do scientists draw conclusions? Learning objectives. I will know how scientists keep records in order to share conclusions with other scientists. Today is Tuesday, 14 April 2020. All of you open your book, page 327, 328, and 329. Let's start now. Did you remember yesterday we studied the experiment for the ball, tennis ball? We bounce ball experiment. We use three different surface like carpet, rubber, and wood, and we use tennis ball, and we measure how the highest of bouncing ball. Now, scientists attempt to develop reasonable answer to the question they pose. So to do this, they use evidence from their observation and experiment. Now, for the bouncing ball experiment. Now, you would use evidence gathered during the procedure from the previous pages. A reasonable answer should not favor one opinion over another unless it is supported by evidence. Now, comparing results. The scientists compare results between each other. Scientists often compare their methods or procedures with those of their peers. They also compare their results by comparing methods and results. They have to compare their methods and their results. Scientists can work to find results that can be retested. In bouncing ball experiment, one group can compare their result with another group. Now, they try to explain why the results are similar or different. Maybe they have similar results or different results. Scientists often do this to think of a new question or better ways to perform a test. Who can read for us question number 9? Okay, why is it important to compare results with others? Yes, excellent. The answer is comparing results helps to show whether the methods and answers are reasonable. So comparing results helps to show whether the methods and answers are reasonable. Go further. We have ask questions, form new hypotheses, test different variables, evaluate old conclusions. So, what can you do with scientific results? Ask questions, test different variables, form new hypotheses, evaluate old conclusions. Go further. One, Once an experiment is complete, scientists use what they learn. The result of an experiment can become part of the background research other scientists use for future experiment. An experiment may lead to new questions to test. Also, scientists may also think of a better ways to do tests. Who can read question number 10 for us? Okay. Suppose you wanted to get more Pierce's measurement of how high a ball would bounce off wood. How would you change the experiment? Yes, I would do more trials to get a larger set of data. Now, think back to the bouncing ball experiment. The original question was how high a ball would bounce on different surfaces. Now, the hypothesis was that a rubber surface would make a ball bounce higher, but the conclusion is different. Was wood surface made the ball bounce higher? Now, it may raise questions about the ball itself. Does the ball bounce differently if it's hot or cold? How might it bounce compared to other balls? Who can read for us question number 11? Okay, suppose you wanted to perform three trials to test how high a ball bounced if it was at cooler temperature. How might you organize your result? Complete the table below. Circle the independent variables in the complete table. You see the table? Here you have to write table, and here you write ball. Here table tennis that we use it, ball bounce height in centimeter. Here the first ball in room temperature ball, refrigerator ball, cold ball, and here hot ball in the room temperature. Now here look at this scientist. This scientist make test for this plant. This scientist is testing a pesticide on plants in laboratory. When this experiment is complete, how might it lead to new experiment? The scientist might test the pesticide outdoors or on. Now, scientists often compare their methods, as I told you, or procedure with those of their peers. They also compare their results. By comparing methods and results, scientists can work to find results that can be retested. Why do scientists compare results? Who can tell me? Yes, it could help them think of new questions or better ways to perform a test. Now, suppose you have finished an experiment. You know how more questions than you did before you con- conducted conducted the experiment. Does this mean you did the experiment wrong? Or could there more question about an experiment after you finish? Okay, the result of an experiment could raise more question about the subject being tested or the procedure. But this does not mean I did the experiment wrong. Now here, interrupt. Three students tried the experiment with table tennis ball. They tested materials to see which caused the ball to bounce highest. The chart shows there below. What might account for the different result? Student may have pushed the ball instead of dropping it. They push it instead of dropping it. Now, what question were students trying to answer? Which material causes the ball to bounce the highest? Table tennis ball bounce higher on wood surfaces, as you see here in this result. 77 student B 73, student C 65. Now go it. Compare and contrast. How is evidence different from inference? Yes, Evidence is an observation that is made. An inference is a conclusion drawn from the observation. Now, number 14, I want another girl to read it and answer. Why is it important to do an experiment the same way each time? Who can tell me this answer? Okay. So that a repeated experiment can produce similar results. Now, I want to show you this video.
Hi, my name is Mr. Cormier. Today we will discuss how to communicate results of an investigation. In the science community, it's important for scientists to share the results of their investigations. You see, this helps others to benefit from the work that others have done. We have conducted an investigation to record the amount of precipitation that fell in the month of November. We recorded our data on a data table and displayed it on this bar graph. The last step, and perhaps the most important, in an investigation is to communicate our results. In this investigation, we can present results in a couple of different ways. We could talk about how much rain total fell in the month of November. How would we determine that? Well, we would add the results together to get the total amount of rain. If we add our results from this experiment, we would conclude that our total amount of precipitation in the month of November is 30 centimeters of rain. We could also present more detailed findings. For example, on which day did we receive the most amount of rain? November the 9th, with 6.5 centimeters. How many days in November did not receive enough precipitation to record? That's easy, 22 days. What is the average amount of precipitation we received per day in the month of November? Well, to find the average, we add the amounts together to make 30 centimeters and divide by the number of days in November, which is 30. Our answer would be 1 centimeter of rain per day is our average amount. In this lesson, we discussed ways to present our recorded data from an investigation. You try it. Using the results from an investigation that you have conducted, find a friend or a grown-up to present your results to. Be sure to be clear and detailed in your presentation. Remember, you are helping others learn with the results that you have gathered.
Thank you, my dear students. Tomorrow we have another new lesson. Thank you.